Hi folks, this is Module 2 Novice Problem Solutions. There are more problems in this set than some of the others, so I'm now going to solve problems 7 and 8, and I'll leave 9 and 10 as the last one. So this is solutions for 7 and 8. Let's go to our worksheet. These are relatively simple problems. Here we have some data. And this is the kind of the form of that we see data in all the time. There are many variables, some of which are numerical, some of which are categorical. Counts, for example, categorical variable. Numerical ratio data is 4,000, and interval data is the date. Okay, and we also have the age of the customer over here, which is ratio data, and a lot of other types of categorical data. So the problem asks us to look at amount and to take that column of numbers, which extends pretty far down, I think 350 data points, and we're going to do some analysis on that data. We'd like to calculate the quartiles, and we've done that in this particular calculation. This is an Excel calculation for quartile. Notice that it has a .inc. There's a .exc also. We generally use the .inc, and I won't get into the details why. This function captures all that data, not capturing the title, of course. Here's my array, the data, and then I place a quartile that I want there. In this case, 1. So the first quartile, in other words, the lower 25% go up to this value of 2,000. In this particular cell, we do the same data, except we're looking for the third quartile. The reason that quartiles 1 and 3 are important, because we often measure the dispersion in a variable as the difference between the third quartile and the first quartile. We call that the interquartile range. Now we're going to use Minitab to do some graphical analysis. So let's grab our data amount. Let's copy it. Let's go to Minitab. I'll put it here. Here's our data. And what kind of a graph did I want? I wanted us to do a summary of that data, summary report, graphical summary report. So let's go back to the data. Let's go to stats, basic stats, graphical summary. We want amount. I select it, hit OK, and there's the data. This is highly skewed data, skewed positively. In other words, the tail, there are values in the upper tail that extend far out. This particular distribution is going to have a mean that's higher than its median. Why? Well, because there are a few outliers. It'd be like asking about income or wealth, and Bill Gates is in the room as one of the wealthiest men in the world, possibly the wealthiest man in the world. So the average in that room is going to be very high simply because of him as an outlier. This is interesting, an interesting summary of data. We have all kinds of statistics here. We have the mean, we have the standard deviation. The median is 4,850. That's a second quartile, by the way. And the mean is 7,558, higher than the median, which is what we expected. And notice in this little plot here, this is a box plot. These are whiskers out here on the end of the box plot. You see all these little asterisk values? These are values that extend so far from the interquartile range that they can be considered outliers. These are all outliers. That doesn't mean we get rid of them. Just because you're an outlier doesn't mean you're not worthy of staying in the data, but we have to make some decisions about how we view that data. Okay, let's go back. I copy that, bring it back to my Excel, and then the question asked me to calculate the interquartile range, and that's simply the third quartile, 12,000, minus the first quartile, 2,000, and the difference between those is 10,000. Now let's do practice problem 8. In this problem, we're going to create a table, and we're going to do manipulation of the table to tell us something about the relative values that appear in that table relative to totals. Here's our data. We have 1, 2, 3, 4, 5 ports, and we have that we run, and we have an administrative, a rail, and a trucking cost, and a total cost of operation for all of the locations. Here, the grand total. This is what we'd call the row total. This is what we call the column total right here in the blues. These marginal values are column totals and row totals, okay, because they result from the row and from the column. The first question is, what percent of Paradip's total expenses are a result of administration? So I can strip out Paradip. I can just grab this data here, and bring it over here, and that's what I've done. And the way I calculate that percent of Paradip's total expenses that are administration, here's the total expenses for Paradip, 1,830. And I want to know what administration is, and I can set up a formula that says take the administration value and divide it by the absolute address N18. I can drag it over and calculate for the others also. So you can see that the absolute value there is, or that the value of the percentage is 12.6%. If we add up all these percentages, they should add up to 1. In the second question, what port has the highest percent of rail relative to grand total? So I'm going to be taking all of this data, which is what the data that we had over here, and I'm going to convert it to a different table where I take each one of the values in the cells and I divide it by the grand total, which is N29. So if I'm clever and I can copy this thing down and copy it over because of the relative and absolute addressing, these are the values that I get. I do it for the entire table. I could have done it just for rail because we were interested in the percent of rail as a grand total, but I did it for the entire table so we can have it for all administrative rail and truck areas. And here's the value that we get for Helsinki, which is the highest expense for rail of any of the locations. Okay, all right. That concludes solutions 7 and 8.